So we do have a notepad on which we'll take notes for the meeting. I don't know if anybody who's on the call wants to volunteer to type into this. I have a copy open here, so we'll try and maintain a live set of notes for the meeting. Please log into the note tool if you're able and contribute to it. So this is the September 2023 interim for TSVWG. There are two co-chairs for the group, me, Gori, and Martin, who unfortunately can't be present today. He's in another meeting somewhere else. This, like all other IETF meetings, is covered by the standard IETF Note Well. You must adhere with the IETF policies, even if this is an online meeting, and you must observe the rules for submitting materials and contributing via email and discussion in the interim meeting. For details, see the Note Well. We do need a note taker, and we will take notes in the hedge doc associated with the meeting.
Gary, I can take some notes if you want.
Please do. Please type into the notes tool or send me notes. That's so wonderful. That's Hannes, is it?
Yeah.
Yeah, excellent. It's good to have notes to know what we did. Right. Next slide. We're going to use Meet Echo, so you know to use the hand tool. If you can't, use the chat, and we will try and follow both and get people in the queue to discuss things. I've only got one status slide because most of the status is not relevant to this particular interim, and neither is this, but it's useful to know what's happening. We are about to do a final review for the ECN encapsulation and shim drafts. Our main goal of that activity is to make sure these drafts are correct with the more recently published L4S specs, and then we'll be submitting those to the IESG for review via Area Director. So that should all happen in the next couple of weeks. We are going to talk about UDP options, and that's completed its first working group last call. There's been a lot of discussion since, still a lot of things to finalize, but we're making good progress here, and hopefully we'll talk about that more at the end of the meeting today. So the agenda looks like this. We have been through the agenda and Note Well. Does anybody have anything else that they think we should be talking about at this meeting? Apart from the fact that Magnus can't hear me, which is going to be annoying because he's the first speaker. We've completed our liaison update to and from 3GPP, which I'm hoping Magnus will go through. This is with 3GPP SA3 and RAN3, and it relates to the extensions for DTLS with SCTP, which is our first topic on the agenda, SCTP and DTLS. We'll talk about the proposed milestone updates on the documents associated with this work item, and we've got a presentation from Michael Tuxon, which is also related to this area. Finally, we'll look at UDP options, and we'll go through the issues list. We are using an issue tracker for this, and although Joe can't be present, We do have his inputs into that issue tracker, so we'll quickly review those to see if we can continue to make good progress. Excuse me, I've got a bad cough. Finally, we will use any remaining time to look forward to the next TSVWG session, and I think that's the agenda that we currently have. Does anybody have anything they think should be added to this agenda? Then I'd like to turn the floor over to Magnus, and perhaps we can introduce the liaison and the progress with that, and then proceed on to the various items. Magnus.
Yes, I hope you hear me now.
We do. Excellent.
Good. So, and you can maybe see me also. Let's see. Had you uploaded these slides or?
Yep. The slides are uploaded, so you should just be able to. Do you want me to share them?
Let's see. Let's see if I remember how we do this.
I think I just clicked that button.
Yes, and I find the slides. Yes. So now I have control. Thank you. So DTLS for SCTP is the topic here. Let's see if my headset can keep on and not mute. But I'm Magnus Westerlund, and we talking about the two different set of drafts here, and we will a little bit high level here. My primary goal here really is my headset's turning off. So consider understanding the requirements here, understand the different trade-offs between the two solutions we have, and be able to enable a consensus call on the direction. That's really where I want us to be at the end of this meeting. So, there are IPR declarations here. I have a verbal statement. Let's see. I think I'm going to have to switch speakers soon, but one moment. So there's one set of IPR disclosures on DTLS over SCTP BIS draft. There's non-disclosures currently on the SCTP crypto chunk. And there's two sets of disclosures on SCTP crypto DTLS. What Eric Yes, we're coming to the liaison statements. They are next in the slide. I wanted to just preface this with these IPR declarations because I think they're relevant and I have them here. I can go back if you want to talk about the liaisons first, but they're coming next. But I want to make one verbal statement here, which is relevant. I'm going to have to switch this, but Ericsson is going to make ensure that you don't need a license to implement the kernel parts of crypto DTLS. So to be able to
Magnus, you appear to be disappearing in your audio.
Yeah, I want to get that correct in the minutes. I didn't quite.
Do you hear me now?
Okay.
So,
right.
Okay, let's make verbal
Magnus,
statement. Yes.
Yeah. Can you rewind and give the IPR disclosure again so we know what to minute?
Yes. So Ericsson will make a new IPR disclosure with the goal of ensuring that there's no need for a license to implement the SCTP crypto DTLS solution. no license needed for the parts of an SSTP implementation that needs to be reside in the kernel for an SSTP implementation in the kernel. The actual disclosures is underway, but it's going to take a while before we have finished all the details of it. But we foresee it's being available before the next IETF meeting.
Thanks. I think this will be a great help to have some clarity on the where we can go and how far the IPR will reach. I see Michael is in the line. Can we take a question now from Michael?
Yes.
Go ahead.
So I think it's good to have something I can implement in the kernel without IPR things, but both solutions, no matter what we finally do, requires a detailer's handshake in userland, I guess. Which means I can implement stuff in the kernel, but I'm not able to test it. That is not very helpful.
Yeah, but that's the situation. Already saying I think you can test it, but you can't release the test code in that case, maybe. But that's, I think there are ways around that. But yes, for your actual testing. But yes, it's when you're actually needing a license, etc. That's when you would run into the problems.
I mean, at least I would need an API to the kernel part, which I can test against. And I can say, okay, the API should behave like this. I can test this, but I can never test whether it actually works. The whole solution. But okay, go ahead.
Yeah. So, but that's at least where. So look, the IPR disclosure will show up later, so that you will actually get the exact wording in place for what it says. So.
Yeah, thank you very much for doing that. That'll be a useful thing to have. Carry on, Magnus.
Yes, now we're getting to the liaison statements. So, and I think we can rapidly go through. This is backgrounds from the previous liaison statements. And at the end of the, this is what we sent out afterwards, after the meeting, the last IETF meeting. We sent out a number of questions. We sent out a statement with a number of questions to the groups, etc. And we have received 2 answers, one from SA3 and one from round 3. And if you need to look at the details, I would recommend that you go, if you haven't done it yet, go to the data tracker and look up the LSs. So, but let's first look at the response from SA3. So this is, you see the link there. So they answered on the first question, is the IETF-TSVW's interpretation of architectural and security requirements correct? And that's what was listed in the license statement we sent. And they answered that from SA3's perspective, TSV's interpretation of all the security requirements is correct. They are generic best practice properties of a security protocol. So that was one answer they gave. The other was, does SA3 have any additional concerns with the implementation of either of the candidate solutions? And the answer was solution 1, which is DTLS over SCTP, requires change in existing SCTP, SCTP OAuth standards, implementation, and DTLS library. Therefore, solution 2, one's implementation effort appears to be higher than solution 2, and 2 is DTLS encrypted chunk. And on question 3, which of the 2 candidate solutions are preferable to SA3? They said SA3 prefers solution 2, DTLS encrypted chunk, due to the answer of the previous question. So that's kind of what the answer statements they have. For the full statement, go read the link. Any comments on this? Michael?
Do they, for the comparisons they made, are they looking for the crypto chunk? Are they looking in a pure userland implementation, or are they considering, because in my view, that's a major difference in the implementation effort.
Yeah, I can't answer that in detail. I think this is kind of a summary of the views that those who made statements in the SA3 working group is what went into the LS.
Okay.
So, ready?
Yeah, hi, Thiru from Nokia. I was looking at the implementation of Nokia, and we are using SCTP for several interfaces, like you have in the license statement, but it's all currently open source. So we are more looking into if it's possible, right? I mean, we are looking for a solution that could be done in open source itself, so it makes it quite easy to do the transition from SCTP to secure SCTP. So that's what I hear from several teams which have been involved at Nokia who are currently using SCTP.
Okay. Yeah. And you, Charles, do you want to make any more, say anything more about your, yes, Charles, go ahead.
Yeah, let's see. Yeah, I just wanted to say really the discussion stayed more up at the kind of the requirements level. Really didn't get into the details of the implementations either in SA3 or from what I can see from the RAND group either. We probably need for SA we probably need to go to a corresponding CT group that would then work on whatever SA3 ends up putting in the specifications. There'd be a corresponding, I don't know if it'd be CT1 or CT4, but would probably have to go off and figure out more of the implementation details. So that discussion wasn't really the kernel space versus user space and the impacts on one versus the other wasn't really a topic of discussion.
So Charles, which group were you referring to in 3GPP?
That was in the SA3 group. I was in that meeting when it was discussed.
Okay, thank you.
Okay, so I guess that was the SA3. Let's go to the RAN freeze response. Thiru, anything more on SA3s or? Okay.
I heard the same response from some of the delegates who attend the SA3, and what I heard from them was they have not done any deep dive discussions on the solutions, both solution 1 and solution 2. I think if maybe the answer is mostly from an implementation effort, but there was no deep dive discussion on comparisons of the pros and cons, deployability, and then the threat vectors or any such analysis was done. So I couldn't hear any such receive any data from the SA3 delegates. So that's the latest information I got from them. So if there is anything else that you have, you can please share.
Yeah, no, I don't have anything additional. I just wanted, so. John?
Yeah, 3GPP very seldom discusses implementation details like kernel or user space. I think that would differ between different companies in 3GPP. I know some companies will likely implement this purely in user space, others might do other things. Yeah, I think also there's often not any detailed discussions in 3GPP. Companies read up this on, sometimes it's very little time, and companies are expected to read up beforehand. I know one of our competitors had a very strong preference for solution 2 when they came to the meeting. So I don't know if I'm not sure we will get any of these things from 3GPP.
Michael?
So if 3GPP doesn't look into these implementation decisions in detail, we just should not use a comparison made by them as a basis for our decision. Because from my view, what is simpler depends heavily on which implementations you use and so on.
Yeah, I agree. There's difference, especially on this implementation, etc. I think I think it's reasonable here to make our own assessments and then take this into account what they're stating. So, Charles.
Just the one request I would have, I don't disagree with that, with making our own assessment. I think that's probably the right thing to do. But if that assessment leads to doing something other than what SA3 kind of just gave is their preference, then as long as we describe that back in liaison and why we went that way, I think that would be completely fine. It wasn't like it's not like a mandate or anything like, oh, we need option 2. I think that was, they were asked a question and they tried to provide an answer based on, the knowledge and research of people who were in the room. And so if we feel we need to go a different way, I think that's totally fine. I would just want to see a liaison back to them as to why we did that, so they know it wasn't us asking and then ignoring their input.
Yep. I think that's very reasonable. So let's go on to at least review what the round 3 LS said, what the core response was. So they, on the question about confirming whether implementation possibilities in both user land and kernel implementation of STP are required for a solution, and whether there are any additional concerns to implement either solution as perceived, they basically said, no, we're not discussing it. Usually not discussing it, and they haven't discussed it in this case either, is my conclusion. But on the other thing here, it's confirmed the interpretation requirements is correct, in which STP message would be required to be supported. In other words, are the theoretical maximum message size mentioned above relevant to be supported, or would it be sufficient that a smaller message size is supported? And round 3 would like to confirm our previous answer. We do not expect to limit the maximum message size of application protocols. For this reason, any solution with a limit on the message size will not meet round 3 requirements. So, which means that they want to have the possibility to make even larger messages than what was reported, what we wrote in the previous in the slide sets, etc., where we had identified. It's actually, I think, on the next slide. Yes, these 142 kilobytes and 500 kilobytes. So even larger messages than that is expected to be supported. So. Okay, so that was the status of the LSs at least. So I think it helps a little bit to knowing that on the message size, that answers one question at least. So should we go on then into some discussion, etc., about the 2 solutions and comparison, and see if there's any. Have a discussion and try to answer any questions if there are anyone around these 2 proposals, so we can get towards.
I think we should. Yeah, that's what we should be doing, Magnus. Go ahead.
Yeah. So there's 2 proposals. So details over STP. This is described in details over STP BIS, and it also has a dependency on an updated STP auth document. That's why it's listed the taxon TSP RFC 4895 BIS. And this is an upper layer protocol, an adaptation layer with details STP layer, an STP stack with STP auth embedded in it, and that you push down keys into the authentication layer. And the user message gets fragmented into fragments that's small enough that detailers can protect them in each record. And then you put them together to protect the user message that you then transmit. And you rely on STP auth to ensure that there's no injection of or reordering of the detailers records in protected user messages. it uses parallel DTLS connections for rekeying. So you have one DTLS connection up. When you want to rekey, while maintaining the first, you create a new one, handshakes the keys, start pushing down, start using those keys. And when you know that all messages with using the old keys has been received and decrypted on the receiver side, then you can terminate the first DTLS connection and completed one rekeying sequence. I would note that the draft text in the current DTLS over SFTP draft might not correctly reflect all those vulnerabilities we recently discussed, etc., the last period of time, etc. So, but I think this correctly reflected in this presentation. We come to this. So that's the core of this solution. And then we have the other proposal, DTLS in CryptoChunk. So that's two drafts. One is the, so say, CryptoChunk, which is implemented inside the SFTP stack. And then there's a protection engine specification, which defines how the CryptoChunk encapsulates, with help of protection engine, securely each set of SFTP chunks that goes into one SFTP packet. So this is a mechanism on packet level. There've been some changes, but we kind of agreed on getting towards the, when you're going to do the key handling the DTLS handshakes, etc., you're doing that over a data chunk. You send it as user data with its own PPID to identify those messages. So you can, and that's the arrow that goes through the stack. That's a handshake message going over to the peer from the protection engine key management part. And then you can have a part which is more, for example, integrated into kernel, where you do the record processing and you have an API with keys and a record specific protection specification. Like, and for DTLS, we're using the DTLS record layer would then be handled in that layer. We use a very similar mechanism for rekeying, that you establish a new DTLS handshake. When the handshake is completed, you start using the new keys. And the CryptoChunk itself identify the key epochs, or as in the connection that's been used, which means that you end up with, you can identify it. And as this is per packet level for each SFTP packet that gets protected, your DTLS is basically working on in the transmission order of SFTP stack, while in the previous solutions, you have some aspects of this being on how the messages is arriving into the stack and being processed rather than how they're transmitted, which is relevant for some of the future questions we're going to discuss. And in this, in DTLS in CryptoChunk, all the fragmentation is using SFTP's normal message handling, because it's fragmented into data chunks, which is then protected after they've been fragmented, which gives you protection of all the SFTP's chunk types inside the packets. So after the handshake is completed. So that's the overview. Any question on the overview? And otherwise, I will go into the comparisons. So one aspect of this, which is fairly significant, is the rekeying robustness. So DTLS in SFTP chunks, when it's necessary to rekey either periodically or when you reach some data limits, you initiate the new DTLS handshakes as STME message with its own PPID. When you completed the DTLS handshake, you derive the keys and for the transport protection, install them, and have the related connection ID identification field in the CryptoChunk flag field. And as soon as the handshake has completed, you can start using the new keys because it's, you know, it's in place in the other end. You can leave the old keys in place to drain any network of any SFTP packet protected in old key. And because these packets basically
last user keys until they will arrive is on the order of what it takes to gets across the network, etc., reordering, anything like that. So here you could implement a very simple solution on when you can terminate the old, and like a 2-minute timer will be clearly sufficient for having any packet being received or being dropped by this network. And then you close the old. And if you would actually close it as soon as you just get the handshake, you would only result in some packet loss. In details of SCTP, the process is similar, but here you have 2 layers that interact. So you have the SCTP auth because you derive keys from the detailed handshake for the SCTP auth. You start using the new keys, and here's some problems. For example, if you're using an API like the ones described in 6458, you can't switch the SCTP auth keys in the middle of a message. You could, in general, you should be able to do that. If you have another API, you should be able to do that. There's nothing preventing the protocol or receiver to figure out which keys was used. The challenge here is to figure out when all the TLS records being protected by this the old key has been received and decrypted before you remove it. Which means that you probably need to have either a more deep API into the SCTP stack and track all the datagrams. One moment, I will just finish this, Michael. You will understand when. So that's one way of doing it, tracking all of this. Or you could also basically drain the connection, or the association. If you stop sending, wait till the session is empty, which also is fairly easy to figure out. Then you can stop. You would know that you have received everything and can actually drop the old key. So, Michael.
Why do I need to know that it's decrypted by the peer? So the SCP authentication layer already takes care of when is a message protected by an auth key act in a non-renettable way. So that means
yes.
I never have to retransmit it. I think I can remove the key once that is done.
Yes, so that's assumption that you would decrypt the TLS record that's being reconstructed in a timely fashion. So if you close the TLS connection and remove the keys on the TLS connection before you decrypt the TLS record, you will screw up. But assuming that as soon as you get the full record decrypted in a timely fashion, the non-renegable way is probably a good indication of when it could have been decrypted. But they're actually not the formal synchronization between these 2 layers, because it's happening in the adaptation layer after the SCTP stack has delivered data to the adaptation layer. So that's the challenge here.
Okay. I mean, so you mean when do you need to have, you need to distinguish the sending and receiving side.
Yes.
One thing, the job of the sender is just to make sure all data is at the peer. And
yes.
when the peer has everything, it can decrypt and so on. So the sender can remove its state. The receiver needs to drain that all messages using that auth key have been processed in userland. Then it can free the connection.
Yeah.
The details.
So it's yes. So I mean I think this is if you just is robust in your implementation when it comes to DTLS connection is that okay, before you close the connection, let that just verify that you actually have processed all the records, because at this time you would have it in your receiver buffer.
Yep.
Yeah, it's you would avoid the problem. So.
Yep.
So Hannes.
Yeah, I was wondering like this in general, this sort of rekeying operations are of course, always a little bit annoying, but it's not the end of the world. It's like we need to describe the timing of when you can discard keys and when you switch. It's like also implementation wise, it's not a drama. Like this is standard business in a key management protocol. So I think with the words you're using, like draining, sounds like we are having a flood here or so. But in fact, this is a sort of routine operation.
Yeah, but it does. I mean, if you do draining, you're actually impacting the higher layer, the upper layer protocol, because you basically have to stop sending until you confirm that all the data has been delivered that you had outstanding before you start sending again. So that has latency implications on the application protocol. And in this case, because of the layering, I should actually go back to, let me see. So the problem here is that you're draining down in the SCTP stack here, while your scheduling of sending of these fragments is not the same as your transmission order on SCTP layer if you have multiple concurrent streams or user message being sent necessarily. And if you get packet losses and wait for repair, etc., you get things out of order here. And that's the extra complication that for this DTLS or SCTP stack.
Yeah. I think you're making problems here that actually don't exist. But
it's the problem is having a very firm understanding, is knowing when you deliver the data and being certain that it's been delivered so that you can close the old DTLS connection.
Yeah, well, having like working on implementations would obviously provide us some insight, but on some of that. But there's, with the prior work in the group on DTLS over SCTP, there's already some experience. But
yes, but that didn't have rekeying at all. So, or are you saying if it used DTLS one reaggregation, it required draining? That's what the 683 specifies. It requires you to drain if you're doing a renegotiation, basically.
Yeah, I would avoid talking about draining altogether, because it has this sort of dramatic sort of.
That's the word that's used in the previous specification.
Yeah.
And it's what's in the SCTP API also.
Yeah, so it's just right. This is nothing Magnus has chosen. So that's true. We drain on renegotiation, and the reason is that when we switch on the DTLS level to a new epoch, at that point of time, we want also, so you get rid of the old DTLS keys, and at the same point of time, we wanted to get rid of the DTLS, the SCP auth keys. If we discussed this, this seems to be, it seems to be okay to keep the keys around for a bit longer at the SCTP layer, and that would mean you can avoid the draining. But he's right. The RFC as it is today uses draining, and that's why we were very strict on getting rid of the keys. But this can be worked on.
Yeah. So it's just that it's a fairly complex process requiring potentially either tracking or etc. Because the problem here is that if you get this wrong, you basically have to abort the SCTP association. So that's just the kind of warning flag why this matters. So, but yeah. Okay, but I think that's the situation here with when it comes to rekeying, at least. So then we have SCTP replay protection. So, Tiru?
I had a question on the previous slide, right? I see you have brought up several issues with DTLS over SCTP, right? So are these problems more like that can be solved by implementations, or is it like the protocol itself is issues that can be fixed, right? I mean, I see some of these issues are mostly related to the way it gets implemented, and it has to be done in the right way. But from a protocol perspective, do you see any issues that needs to be fixed as part of this one?
So I think we arrived at the process that works. It's just that you have to be as a sender, you have to be very careful about understanding when you fully deliver the data. And there's different way of reaching that step, but it's either you need good integration with STP stack, or you can drain the whole stack. You have options, but that's basically those you have. So
got it. Okay.
So
Thanks.
this work was done at a point of time where we could influence the socket API RFC. So the socket API specifies the level of interaction you need with the SCTP stack to implement DTLS over SCTP. There are no special hooks needed or something else. But Magnus is right. You are programming against this API, and if your stack has a bug, the consequence might be that you lose the connection, but this can happen always.
So, Martin.
Hi, no hats, but maybe this is a silly question, but like while we're here messing with the protocol, like would it be possible to instead like create a way to rekey STP auth within the context of a connection? Why does that not work?
So Michael, you go ahead.
So the STP authentication supports 64K keys in parallel, and they can be changed during the lifetime as often as you want.
Yeah. But it's the two layers here, I think, which is it's the integration between the DTLS layer on top of the stack and the STP auth keys in the stack, and knowing how these keys interconnect, etc. I mean, the STP auth keys, that failure to authenticate a packet would mean a packet loss from the STP sender perspective. But it's the losing the DTLS record is a really bad event, because the sender believes you have delivered it, and you have it has delivered it, and there's no way of dealing with that. But yeah.
Pointer. So the other stuff is, I mean, the RFC is implemented in OpenSSL and runs on Linux and FreeBSD. Two kernel implementations supporting the socket API. So this is doable, and it's available.
Okay. So replay protection. So here we also have some differences. DTLS encrypted chunk. Here we can actually use the DTLS replay protection that exists in DTLS to avoid replay of older SCTP packets. So, and that because they are transmitted basically in the order SCTP is transmitting the packets, DTLS is sequence numbering them and using that for its replay protection. Its replay window only needs to be as big as the reordering expected between the paths, because it's going to be across all the paths. And it provides a strong protection against availability attacks, because replaying an old packet here will not work at all, because it will basically just be dropped by the DTLS encrypted chunk layer when the packet comes in and is out the window. In DTLS over SCTP, SCTP auth doesn't have any replay protection, but you have some interaction between the knowing that the packet is authenticated and the data chunk processing, for example, for the data level. And data replay can only occur after a TSN wrap, which means that it's after 2 to 32 data chunks. So if you rekey at least once every 232 data chunks, you can prevent the replay from happening and entering data into the higher layers. So the only real significant difference, if you're doing that type of rekeying often enough, is that you have no general protection against this. And this is for STP chunks that doesn't have sequence numbers, etc. Those you really can't track in those cases. So it comes down to how robust your stack is getting, and you replay the control chunks. Michael.
So when designing SCTP, we were definitely aware of attackers might replay packets for whatever reason. So the procedures in the protocol are there to deal with it. And even if you don't want to rely on this stuff, you can always use auth to protect against this stuff.
Well, you're not protected against replaying previously sent packets, even with.
Oh no, not replaying. Okay, but I mean,
Yeah.
it's you got the packet once, you can get it twice. It's like packet duplication happening in the network, and that's fine.
Yes.
That can happen all days, and I think SCTP should protect itself. I mean, I would expect an SCTP implementation to protect itself against it. There is no need for another entity.
Yes, but I mean, they are yes. So this is noting that there are a difference here. There's, especially if you have a deliberate attack that you delay a packet significantly more than what you expect from the application or anything to happen. If you get in 2 errors after each other in a short time, okay, that was the application. It's about if you would get an error message that was from 30 minutes ago being replayed, you might react to it instead. It's that type of things. And it's like, yes, it looks like SCTP is robust to.
So that's perfectly valid to replay a packet from yesterday. And I would expect the protocol to deal with it. So can you come up with an example where such a replay would have any impact?
Not in a well implemented stack. No, I don't think so. There were no super obvious big holes here if you have implemented this correctly. It's down to
I mean, can we distinguish between the protocol and implementations? So I think the protocol is fine with it. Implementations may have any bugs.
Yeah.
Well, I think we should focus on the protocol.
Yeah. Sure. I just noting the difference here is that on the left you even have a protection against implementation bugs from replays. So for the TLS encrypted chunk. So
again, but I would still like to see such a bug. I mean, I'm aware of several bugs in various SCTP implementations, but I'm not aware of a bug where this kind of stuff would be critical. But okay, go ahead.
Yeah. So okay, let's see. So on performance, okay, Tiru.
Hey Magnus, I have a follow-up question. Did you see this bug in any of the existing implementations that raised the alarm, or like any of the open source SCTP implementations where you noticed this kind of vulnerability and that needs to be fixed, or this is more of like a theoretical assumption or something that you tested and you figured that, hey, this is a common vulnerability that you saw in multiple stacks?
No, we don't know. We don't know about the commonly occurring. It. The only we went through the protocol, noted places where at least you had some potential for confusing information because you couldn't separate if it's replayed or not, etc. But it's basically on the level saying it's informational message arriving out of expected time windows or its sequences. Basically, that's the thing that can occur, and it's limited to a few particular messages, which is both of informational type. That's what we noted. We don't have concrete examples of this, of any particular implementation or something like that that has a vulnerability.
Got it. Thanks.
Okay, so when DTLS encrypted chunk, it performs a single set of cipher operations on each record, and it's going to depend on the cipher that's being used by the protection engine. DTLS over SCTP, it first performs a DTLS cipher operation on the content of the data chunks on each fragment. And then for each SCTP packet you perform an SCTP auth protection of the SCTP packet using HMAC SHA-256. this has slightly different overheads. The DTLS encryptor chunk will have a smaller overhead because of the SDP auth's large tag, basically. Even if it's the DTLS record is per packet. So, Michael?
Just a question, since I've been out of the working for a vendor for almost 20 years. So the nodes this protocol, or one of this protocol, will be deployed. Are they running on CPU limits? I mean, is the CPU performance critical? I mean, I'm always for saving CPU cycles, but is it something like you need additional hardware if the CPU cost goes up 10%, or is it? So I have no feeling whether these are saturated.
No, I think it's actually no, not from processing requirements for deciphering. I don't think that's the primary. There's a difference, of course, because you're doing 2 levels here, but for the details of SDP. But I don't think from our perspective that's just noting that there are a difference here, and there's some byte overheads that's larger on the details of SDP too.
Yeah.
So.
But it's not critical from an operational point of view.
No, I mean at least the 3DPP usage is in signaling protocols, in the control protocol parts. So.
Yeah, that's what I would expect. Thank you.
Yeah. Yes. I mean, there's a general trust in DTLS as a good and living and maintained protocol, which is good for both sides. But I would say the SDP auth, I mean, based on the found security bugs, etc., there haven't been it's not as well studied. There are fewer implementations and etc. So SDP auth here is a little bit more uncertain from a general trust perspective, I think, from knowledge about any weaknesses in the protocols. So.
Magnus, likewise, one could argue that the crypto chunk is not widely implemented either.
No, but that's true for the DTLS layer, also DTLS layer on top of SDP, which is gonna do the key management and those processes too. So yes, right. In both cases we're introducing a certain set of new procedures, etc., around these protocols. And that's true for both.
I think what I was pointing out, the arguments apply to both sides here on these extra extensions.
Yes, those extensions extra, yes. Yeah. Michael?
So yeah, so I think one of the things we should which we should consider is that I think which solution we choose doesn't matter. It should be possible to look at the implementations, look at the protocol, study the protocol, allow review on the protocol and also on the implementation level. That's a good thing in both cases.
Yeah. So, I mean, that's part of why I want to make it, so saying try to get as soon as possible to a decision towards direction here so we can focus on getting through and review it properly what we're doing here. And getting prototype, getting implementations, etc., experience too. So, okay, but let's go on. So when it comes to message size limits, for DTLS encrypted chunks, there's no limits, the same as in normal SDP. And with SDP, how did I manage to not fix this? Okay, DTLS over SDP. With a good SDP API and tracking, there are also no limitations. if you would have the 6458 API, you might have a limit, but it's really, really large messages. It's the time, how long it takes to transmit the message can be no longer the time it takes to until the next rekeying, basically. So you can have a reasonable way of sending very big messages with both solutions, and I think that's they both, from that perspective, fulfills the requirements. Gary?
No, I was just going to ask. So both seem to pass this, and
Yes.
I think that's what you said, isn't it?
Yeah, exactly. So I think both if meets 3DPP's requirements. So implementing these, DTLS in CryptoChunk. So that requires implementing the CryptoChunk in the SCT stack. And if you have a kernel SCTP implementation, that means you have a kernel impact. You need the DTLS protection engine wrapping of the DTLS. So that's some code around that and fitting it to the CryptoChunk. Especially for userland stacks, we really expect available DTLS implementation to work and be easy to integrate. For the kernel implementation of DTLS record protection, that means you have to have some type of split DTLS implementation. You need to take the DTLS record processing connected that to the chunk processing in the kernel, and likely a new API for the crypto context for that. So here there are differences depending on where you implement it. For DTLS over SCTP, there's an update of the SCTP auth required for the SCTP stack to implement whatever the new specification is that solves the directionality and etc. So we'll have some kernel impact on if you have a kernel SCTP implementation. You have to consider if you need to have SCTP tracking of delivered data, and if that means that you need some new additional API surfaces to your SCTP stack. And you need a DTLS implementation that might require extension or updates to support necessary features, because we have a need for either a DTLS connection ID, need for the DTLS connection ID, as well as an RFC 8449 support, or support for 16,384 maximum site byte records, or some other limit we've said these you must support this size of records we're going to use, as well as saying the wrapping logic for the adaptation layer above the SCTP stack, between the ULP and the SCTP stack. So that's kind of the impact for these two proposals. Michael?
Why do you need 16,384 record sizes? So what is RFC 8449?
It's the DTLS record size negotiation mechanism.
So where you can reduce this?
Yes.
So you want to use smaller record sizes?
Yes. The kind of the interesting my understanding here is that the DTLS stack mostly being deployed may not actually support full maximum size DTLS record sizes necessarily. It might be tested because their deployment has been focused on using them to protect like UDP payloads, which has like they're gonna fit in IP MTUs, etc. So
okay,
and sure, you just need to ensure that if you're an easy way of dealing with this is saying yes, you're requiring for DTLS RSP of a maximum record size DTLS implementation. You just need to ensure that you have one. So okay. Hannes maybe have some input on this. So Hannes?
Yeah, I worked on the implementation in Embed DLS on this. So it's in some sense it's just a parameter. As you know, it has a different length that is negotiated, and the issue is that like how much memory do you allocate before those extensions? It was difficult to downscale, which was an issue for IoT devices. So they had to sort of like allocate the maximum buffer size, which was a challenge. So that's why the extension was introduced. But of course, I didn't check all the stacks, as you can imagine.
No, not. So, I mean, our understanding is based on trying to review the specific, saying APIs, etc., was described about some stacks that's available. And that's why we're saying that there might be some issue here around that size limit, but it probably is a very minor issue, but it might exist. We're just trying to be
happy to look around with you and see what the status is. It's always interesting to know like how the developments, implementation, deployments have catched up.
Yeah, we're getting to a bit to the DTLS level here, and which is so far we have been looking at supporting both DTLS 1.2 and 1.3 for both solutions, and the reasons here is because of the lack of mature DTLS 1.3 stacks, and we also have some inherent to the limit to the DTLS connection ID requirements. So DTLS encrypted chunks, as I said, needs no connection ID, but the DTLS OSSB needs. When it comes to replay protection, you may use it, and I think actually recommend using it in DTLS encrypted chunk. So for DTLS OSSB, you need to turn it off because of the potential for significant reordering, making the data that arrive out of order, etc. Can cause problems with the DTLS records being not processed and lost. So therefore, you must turn it off. You have the key in interaction with key updates because it's happening on packet level in DTLS encrypted chunk. So it may be used, but the same like the other rekeying problems we have the DTLS over STP, that applies also for key updates on DTLS level because of the unexpected and large potential time distribution between different last usage of keys. DTLS record sizes that we expect to see is for DTLS encrypted chunk is really just the STP packet MTU that you're using. And as we discussed for DTLS or STP, it's 16,384 bytes. And so, Hannes, do you have any you say that OpenSSL is to add DTLS 1.3. Okay, do you have any more details?
Well, that's just I have to look it up, but we asked the OpenSSL team what their plans are. They say it's ongoing work. Someone has secured resources to do that type of work. I did implementation of DTLS 1.3 in MPEG-TLS, but as part of all this work on producing sort of a production quality version, I had to remove that code, and so I can ask my former colleagues what the status is there as well.
Yeah. But yeah, I think the current situation is that there are we can expect to be able to transition to 1.3, but currently already available open source implementations might be limited.
Well, like obviously it's always a huge effort to implement any security protocol, like at the production quality performant level. So it's not like a student project kind of thing. But I expect that likewise with DLS 1.3, people are moving to version 1.3. So of course, the DTLS 1.3 specification was released much after the DLS 1.3, so that of course introduced the time delay. But since you guys are also adding extensions to DLS 1.3 or proposing, and so help is appreciated. Like contributing code to this open source project is obviously up to anyone.
Okay, thank you. So, but that's this on details and requirements. When it comes, there's one interesting aspect here around STP association restart around these. So in details, the crypto chunk, the draft currently describes STP restart for 2 cases. Either you maintain your protection engine crypto context across the restart, and you could do like an init protected by the crypto chunk, or at least a later message that can be discussed how it's exactly done, which would maintain the security. Or you do a plain text init. We notice this has opens up for availability attack on the STP association. And if an attacker forces the STP restart, then the detailless handshake will expect it to be failed because the attacker has no way of responding with the right identity, and it will terminate the hijack session. So, so Michael.
Yeah, since this is on the slide in the slides, I'm not sure if this restart using the crypto chunk actually works, because SCTP wants the verification tag of 0 to be used if and only if there's a single init chunk in the packet, and firewalls might enforce this. So when you put your init chunk after, I mean, it's the payload of a crypto chunk, the question is which verification tag you would use. So if you would use 0, then the firewalls would drop the packet because it's an illegal verification tag. If it's non-zero and you process the init, the stack has to throw it away because it has to enforce that the stuff is zero.
Maybe
so looking at the second one, the attack vector is something you wrote. So the attacker must be able to read packets in both directions and must be able to send spoof packets. So isn't this a man in the middle? I mean,
it's or a competent attacker, maybe a better word for using it. But it's you need to be a highly competent attacker or having access a certain levels here to be able to perform this attack.
So if an attacker can do this, why can't the attacker just drop packets? I mean, are there actually attackers?
You don't need to drop packets to perform this attack. You just need to be able to get a cop. Attacker needs to be able to spoof packets and be able to read packets that this.
I understand this. When we designed the CTP, we protected against blind attackers.
Yeah.
But we said if we have some on-path attacker, there is no need to protect against denial of service things, because an attacker who is capable to read these packets is most likely also capable to be able to drop packets. So he can just drop the packets of the association and you have the denial of service. Is that not true anymore?
I think there's actually a significant difference between actually being able to ensure that the packet is dropped versus being able to get a copy of a packet. So that's just my personal view here.
This means, but this means protocols like TCP and SCP are broken because we have to accept that TCP or SCTP are broken against these attackers because they can they read the on-path traffic and they can bring down the association anyway. Is that something we need to protect against? I mean, do we have a threat? I mean, I would like to see a threat model which says this is what we want to protect against and this is what we can live with.
Yeah. So I think this is something we can continue discussing later. It's just that this exists because I think we want to get towards decision, but it's something we're going to have to deal with in some sense, and exactly what is the acceptable layer. Potentially, this is something you could have a policy flag saying, okay, I don't believe in this attack can happen, or it's not bad enough, so therefore I enable this, knowing what the is. So, Gory.
Yeah, I'm confused by whether this attack is more severe than just seeing every SCTP packets and dropping the ones that you think are the most destructive.
Yeah, but it's the difference here is that you only need spoofing and reading capability versus dropping capabilities. But
Wow.
So and how do you protect against the same attacker just doing this initially? So I mean, it's a denial of service attack, right?
Yeah.
So just do this before the handshake happens, and you're done. Just continuously do this.
No,
and
but that's
without crypto. I just start talking to you over plain SCTP. You associate with me, and then I keep you in this state. So I can do this. I can do this without crypto. And I'm not sure if this is actually. I mean, let's focus on the threat model and then see what threats we have to be, which we can handle, and which one we accept.
Yeah, let's take. I think this is the thing for further future development, because yes, it's just noted it because it's actually, and there's SCTP OAuth requires SCTP OAuth and having maintaining the crypto context to authenticate the cookie echo for restart to work. It's just noting that. And here is the SCTP in 3DP, there's specification 38412, which requires SCTP association restart. I think yes, we probably maybe need to communicate to the people that they might want to review this in a later lesson. So, yeah. So, to conclude, what we see as the kind of summary of differences. We have on the details implementation availability, on rekeying robustness, message sizes is not really a difference unless you, so there's both very large, etc., and fulfilling requirements. You have some difference in if you encrypt the STP control chunks, where details encrypted chunk do encrypt them versus they only being authenticated in details over STP. And that's also related to the replay protection discussed. Hannes?
Yeah, I'm like in DTLS over SCTP, you say implementation ability is poor. It's 100 times better than a proposal that is not implemented at all. Like you already have some features with
it's just for the DTLS stack, and it's based on the requirement on connection ID. I think the connection ID is the long tooth for the DTLS implementation of DTLS over SCTP. That's the problem. There's not that many stacks that support of the DTLS implementations for either 1.2 or 1.3 that supports connection IDs.
I think you are comparing apples and oranges, because you're basically saying that I have one feature that I have to implement, and that's why it's totally fine to implement everything from scratch. It almost sounds.
But everything from scratch. So there's several layers of implementation. That's why I talked through this in the implementation spec, saying this is just talking about what's required of the DTLS implementation itself, just the DTLS implementation. Then you have the different wrapping layers, etc., around it, and yes, those are different.
Yeah, I don't agree with your assessment, but it's of course it's a different perception.
John?
I think it's a big difference to make for a company to go in and make changes in the DTLS library implementation and to make changes around the DTLS implementation. You, at least Ericsson as a company, would like to very quickly apply security patches. If you have done any proprietary changes, you cannot do that without any additional work, and you also risk that you have messed up something else in the DTLS implementation. I think a lot of people would rather build things outside of DTLS.
Well, like if you apply that logic, I think it makes no sense to me that in other groups you are proposing to add new features to TLS. Then, but yeah, there are some inconsistencies here.
So if you have patches against libraries and you want to simplify your life when you apply security fixes, upstream your changes.
John?
Yeah, that might be, sometimes it might be hard for company policies and require a lot of work to get approved. And also all open source might not want patches. For example, OpenSSL, I think for a couple of years ago, they stated very clearly that DTLS 1.3 was not a priority and would not happen for several years. And yeah, I don't know if somebody tried to push that, but I know people tried to push a quick API that they liked, and that was very much denied because management want to do things another way. So it's not always that you can, even if you implement it, it's not sure you can push it to some open source project and it will be accepted.
Yeah. So yes. Let's see. And crypto passes on data, it's DTLS only for in the crypto chunk, and over STP, it's first DTLS, then STP auth on different granularities. Implementation impact, DTLS in crypto chunk for user space implementation is for some value of medium, while we consider it much higher for kernel implementation. We do acknowledge that. It's similarly medium to high to do DTLS or STP, depending on looking at both the DTLS implementation, depending on how much changes need to do that, and how difficult it is to get the STP auth changes in place for your current STP stack. So it's I think a lot depends on which stacks you're using, etc. So it's not only our considerations here. I was saying Ericsson might have one view. We're very much supporting DTLS encrypted chunks for several reasons, among them for looking like it's simpler, more straightforward with key management, and provides better properties when it's protecting the whole protocol. But it's I understand we have different views here, and therefore I want to see if there's some additional questions, etc. Because we're getting very close to the end here, and I do want to see which way forward we want to choose, and I want to see a direction here, at least some clear indication, or saying what else is it that we need to really understand. Because I think still there's going to be a year from direction chosen until we finalize the spec at least. And I would like to go towards a hum. So, and I would like to us get to consensus call fairly soon after the interim meeting here. So I would, and then I think, so any more comments, questions, discussions?
I think I'm interested in knowing who thinks they have enough information, or if they don't have enough information, what do they want? So please think about coming to the queue and talking about that. If you can talk about what else you would like to know, or whether you think you have enough information to be able to make this decision. And then I'll let people clear the queue. So Zahid first.
Can you hear me?
Yep.
Yes.
Okay, so Jahid with no hats on. I think this has been a good discussion, good email discussions, and we have a lot of information. One thing that I was thinking like might be really important, because as today we have heard, like there are lots of implementation considerations. There's an attack thing going on. There's like a need for what's going to happen in the kernel space, user space, all these things. I think it would be very important for this working group to actually do some kind of testing or interrupt thing, or like to actually consider the implementation aspects also, even though like Michael said, like maybe we should focus on the protocol part. But I think important, as this is kind of like really touching up on different security things and different level. So I think that would be really interesting to see some sort of like interop or implementation experience shared. I don't know if anybody can share that right now, but yeah, that would be my expectation. And I think it would be really good to actually consider those things as well. That's it.
Yeah. When it comes to implementation, we did an implementation of DTLS over SCTP, a prototype where we failed to, our usual DTLS stack didn't have connection IDs, so we couldn't implement it full out, and it was a bit of a mess, to say lightly. So. Tiro?
Yeah, I think it was a good discussion today with regard to both the proposals, and seems like some of the issues that Magnus has raised can be addressed in DTLS or SCTP, but I think we need much more deeper analysis to understand and figure out the clear winner, and probably some sort of running code or interop would help us to make that decision. But I feel it's too early to go one way or the other without looking into more understanding of which is more feasible to implement and deploy in open source. At least that is the interest for Nokia.
Michael?
Yeah, I mean, I already said whatever solution we choose, it would be very good if people can look at the code, people can look at the implementations, people can look at the protocol and play with it. So the real issue for me is the IPRs on the table. So I mean, it looks like there is the possibility of Ericsson moving. So maybe they can consider that if it's somehow they can somehow choose a license which allows open source implementations to implement the complete solution, not only part of it.
Marcelo.
Me?
Please go ahead.
Cool. So Shinlong and I here are the Linux kernel upstream maintainers for the SCTP stack implementation. And yes, I can see all the differences between the two implementations, but at the same time, one critical information that I'm missing is what is our goal here? Because one solution protects and, let's say, hides more information from the protocol than the other from praying eyes. And is this like a requirement? Is it a goal to protect from it, or just add crypto and protect the payload? Because there were papers that people observing traffic can like infer which movie you are watching just from packet headers. So is it a worry here?
I'm not certain I understood what you're really asking for. You're saying why?
I'm asking what is our motivation here to add DTLS over SCTP.
Jan, I think you might be better to answer this.
Yeah, the motivation is to, I think right now one of the solutions is IPsec hop by hop, and 3DPP wants to have end-to-end encryption over intermediaries, and then they specified RFC 6083. I think SE3 at that moment, stressed with 5G, probably believed that it was DTLS provided everything and it was done. Now it cannot be deployed. I think from a 3DP's perspective, DTLS over SCTP is good enough. There definitely needs to be encryption also inside the core network. That's like not the question. But I think that's probably good enough. But if you design something, if you design something new, you should try to hide as much as possible, and that's what we try to do in DTLS in SCTP, the crypto chunk.
Okay, thanks.
I started a poll in the background to start some questions. The first one, very general: would you support progression of one of these methods? And then, of course, I'm going to ask for the individual ones and see what we can learn. Obviously, this is only a small group of the TSVWG, so it would be good to get a sense of what people thought after that detailed discussion. And feel free to take part or not take part, depending on where you feel you lie in this discussion at the moment. Carry on talking, though, at the mic. I'll leave this open for a while.
Am I next? I'm not sure. I guess I'm next.
Yes, Martin.
Okay, I have. Okay, first of all, no hats, and I'm not an SCTP expert by any means, but a few comments. So, like, I feel a little bit torn here about these two alternatives. I agree with Michael that if the IPR encumbrances are such that we cannot get the kernel bits in the kernel, that seems like a non-starter for the crypto chunk deal. Which I'm not saying that's the case, but if that is the case, I think it's a non-starter. For what it's worth, I think this crypto chunk idea is probably a little bit architecturally cleaner, and and I do think that DTLS implementation shortfalls are a bigger deal than SCTP implementation shortfalls. Like, I think this community can fix problems with SCTP implementation much easier. We can fix problems with DTLS implementation, just given the specialized skill set needed for DTLS. And the final thing I would say is that I don't object to more data, but I also don't want this to become just sort of bring me a rock, looking for the magic thing that's going to. Let me put that a different way. I think we need to precisely define what information we need and like task someone to do that, rather than just sort of hope that doing a little more work will make the answer become obvious to everybody. Because I don't think that's where I don't think that's a productive way to move forward.
I think my turn again. No hats on. So my understanding is like this is a really important problem to solve from a 3GPP point of view, but I do see like this is not the most critical one. I mean, when I look at the implementation or deployment of the RAN protocols in the mobile networks, I think this is still far away from deploying DTLS over SCTP. So we do have time to actually do some more analysis and make a good decision. As you said, I do agree with the things here has been said, by you, Martin. Like one is like conceptually and from the architecture point of view, it's more simple. Another is like you need more detailed kind of like discussions between this working group and TLS working group and other things. So yeah, I mean, I think it would be good to actually do some more kind of like analysis before we go for one or another way. And also wait for Ericsson's disclosure of like the licensing, because if that lets everybody to implement it in open source, the full solution there might be just simply will go for that, one of those things. Having said that, I think I need to attend some poll here.
Yeah, I'm just quickly commenting on the poll. The poll is not asking the question of which direction do we choose, but it's trying to get to a place where we can actually make that choice based on inputs from the group. So I'm asking really for people who would actually be willing to commit time or help define this in a more clear way, perhaps talking to the TLS people as well. And that very much follows what Zahed was saying. So
Gauri, just a clarification. I mean, do you have like a thought in head, like there might be a design team looking into these things and come up with some requirement and potential way forward?
Yes, I think so. I think this is what I'm now thinking of, that we made good progress here. I'm not sure this level of in-depth discussion is great for a TSVWG plenary, and I'm not sure 100 people voting on which one's the best method is going to be the right way of doing it. So I think probably a design team to come up with the requirements for this spec and to clarify some of these things, and perhaps take this to TLS as well and find out what they think about the security aspects.
Sounds great.
And quickly, because this is only to decide what we're going to do, and we should be able to make this decision fast.
Yeah, I don't want to spend another 2 years on this. Thanks.
No.
Yeah, we have seen design teams which are like meeting every week, and we can make quick progress with a dedicated set of people who have a stake in this and want to make this quick decisions on this. In addition to requirements, I think the design team should also look into the threat analysis to see where the threat actors are, what kind of attacks are possible, right? And that a mandatory set of requirements, optional set of requirements would really help evolve these protocols then to really weigh which one is meeting those requirements and then pick one of them in addition to the IPR and other open source implementation. So that seems like a good step forward to make some progress.
I'm right with you on the idea of getting the threats identified more clearly, so we can make sure that we have a very clear message to our security experts. Magnus, do you think there's another question we can ask? I'm not sure I can actually ask on the direction at this moment.
No, I understand that, but I hope that I really think we need to be able to do that very soon after next IETF meeting. That question, because I don't think we can delay much more. So if you're going to have something like design team likely meetings, etc., I think then it needs to be spun up immediately to make progress up towards the IETF meeting and to discuss these things. So in that case.
Okay, if you're on this call and you're interested, then make sure we know that you're interested in part of this activity, developing these technical specs for requirements and security threats. So you need to talk to Magnus or me, and we will try and set up something like this. Is that a suitable way forward for the group? Anybody got any other comments on this proposal for some activity before the November IETF?
So should I write you will create a design team? Is that sort of or what should I write?
You will write, I shall speak to my AD about creating a design team, and people interested should contact me or one of the proponents, so we know their names. Okay, I also have a slide deck from Michael and Hannes, which I think we can share. I'd like to keep 15 minutes or 10 minutes for the end of the session to discuss the UDP options work. It probably only takes 10 minutes, so you have 15 minutes to talk about that slide deck if you think that's useful. Is that something you want to do at this stage?
Yeah, I think it makes sense. So how can I bring up the slides? If I click on meeting things, I see no slides available.
Yeah.
You click on the ask to share slides, then you're gonna, when you get the steps from the shares, you will get the list of the slides that's been uploaded.
Oh, okay. Ask to share slides. Yeah, okay. I have asked.
And you get.
And now I control Magnus slides.
Yeah, because
now I can do change. Okay, yeah.
Yep.
Okay, so this is about RC 6083 BIS. So it's about updating DTLS over SCTP. Not in a way, I mean, not with the intention to fulfill the 3 GPP requirements, but to update the spec and get as much as possible without using IPRs, which I think Ericsson has. So the first thing is pretty simple. DTLS over SCTP. This one or the one from Magnus depends on SCTP authentication, and there are generic things which need to be fixed and modernized, and I don't think there's a disagreement about this. So this is something generic. This is generic work which has to be done anyway. The next thing is regressions from the original specification. So when we wrote the DTLS over SCTP specification, we were assuming that future versions of DTLS provide the same services, and we were wrong. So the first thing is that a new mechanism, key updates, was introduced, and so the RC 6083 does not describe what to do in this case. So this must be specified, and the typical way to do is to update the SCP auth keys. The DTLS 1.0 allows arbitrarily long communications by allowing an unlimited number of renegotiations. This has been dropped in DTLS 1.2 to 2 to the power of 16 minus 1, and in DTLS 1.3 2 to the power of 64 minus 1. So yes, there is a limit, but using DTLS 1.3 seems to be good enough for every practical application. So that's why we focus here on DTLS 1.3. And DTLS 1.0, you can get forward secrecy when you do renegotiation, but this is not possible anymore in the DTLS 1.3 when you do key updates. And that means you can't do this for arbitrary long DTLS connections, no matter whether they run over SCTP or over UDP or over anything else. So this is a generic issue which should be addressed in the TLS working group, or can be addressed in the TLS working group, to allow arbitrary long communications. There are some limitations in RC 6083 which can be relaxed. One is the draining we were talking about earlier during when updating an epoch, and you can, by using a different procedure and allowing older keys to stay a bit longer in the SCTP layer, you can mitigate this effect of needing to drain. What is a harder thing is the user message size. So it's easy to bump them from 16K to 64K by using RFC 8449 in combination with the flex extension, where you say we want to make the message limit higher. And this basically keeps the mapping of a single user message goes into a single DTLS record, and a single DTLS record goes into a user message. If you want to relax that, that's IPR protected by Ericsson. So that's why we can't go to values larger than 64K. And the motivation here is that we think we need a way to secure SCTP user data in a way that is implementable in open source. As you see here, the dependencies, the required ones are generic ones, so it should be done anyway. It's not specific to this. The SCTP stuff can be done in TSVWG. The DTLS key updated key procedure would be done in the TSV working group if necessary. Optional, it's the bumping of the user message limit if you want to support larger messages. So that's how far you can get without using the IPRs we think Ericsson has. Comments, questions?
Yep. Any comments? Any questions? Tiro.
Hey, Michael, I had a question on the DTLS key update. I think, are you saying that you're going to bring in the TLS 1.2 renegotiation back? I mean, I thought it was deprecated because of security concerns, lack of use, and complexities probably. I think I recollect some of the discussions that happened some time back, but what is it that you're planning to bring back with regard to, are you planning to bring back what was prior in the prior TLS versions?
So right now I have no concrete suggestion. The point is it's a regression. So something has some feature which was there has been removed. So I would work with Hannes to see how to deal with this, so to provide forward secrecy when you do a key update.
Got it.
But right now I have no specific suggestion.
And why is the record size increase that you're suggesting with the TLS flags? I mean, that doesn't seem mandatory with regard to the requirement that you could still fragment the messages and send them across, right? So that does not look like a mandatory requirement to be supported, at least for the liaison statement that came from Magnus. So why is that feature critical?
I think the point was that the message size of 16K is not good enough. And what we can do here is we can bump the message size from 16K to 64K, but not larger. Because we want to keep the mapping of a single DTLS record in a single SCTP message, and a single DTLS record can only have 64K. You can fragment your user message in multiple parts, each part in its own DTLS record, and send all these DTLS records in a single SCTP user message. That's doable, but IPR protected. And the focus of this version was void IPRs.
Got it.
Magnus?
Yes. Yes. Talked before when we had a discussion about deprecation of 68, or saying replacing a 683 with DTLS over SCTP BIS or not, etc. I think we shouldn't leave 683 alive, so we need something to either replace it or kill it. So from that perspective, I think it's reasonable to at least take this work into working group and continue working on it in parallel with the bigger solution that fulfills 3GPP's requirements.
Yeah, I guess we'll talk about that in the IETF in November. Can somebody tell me what the status of the TLS flags work is in the TLS working group? Is that something with momentum, something that's going to be finished soon? Do we know?
You're asking the TLS flags extension?
Yes.
Yeah, that's I believe that's completed work. It's waiting for implementation. It's essentially an optimization that one can use to reduce the size of the payloads. In this case, it's convenient. Instead of encoding a specific value, you can basically set one flag and then say, I want to bump it up. Yeah.
Okay, that's what I want to hear. Okay. Well, I think the feedback to Michael is please ask on the list if you see people wanting to progress this. And okay, we can do a call at the next meeting.
Okay.
And everybody on the call, please have a look at it, because the more people we have who have opinions, the better our decisions are. Okay, I think that's the end of our currently scheduled SCTP work. I think it would be useful to look at the slides on UDP options, just for those people who are following that piece of work, so we understand where we are going. So if I can share that slide deck, I will. So these slides are on behalf of the UDP options draft. Joe's working to revise this draft. He's currently responding to issues that are raised in the GitHub, and therefore I think it's probably worthwhile running quickly through the list of GitHub issues. But do look on GitHub if you prefer. Joe's plans will be to produce a new rev of the draft in short time. Rev 24 is already being assembled based on the discussions here. For some reason, my slides go from bottom to top, but maybe that's just for amusement. So I'm not sure. I think if anybody's got comments on these, please add them to the GitHub, or please comment now at the mic. We think that issue 1 might be closed. We think that issue 2 might be closed, and issue 3 might be closed. And these are all comments from the GitHub. So I am going to suggest that we close these if nobody provides additional feedback. We then have a bunch of design decisions we're talking about, some of which have progressed more than others. I think we need to discuss and decide the final shape of the authentication and encryption work, and we are hoping to see that appear in a version very soon. Does anybody have any comments on these particular set of issues? Yeah, go ahead.
Yes, I have to agree with you that I think 1, 2, and 3 should just be closed. Of course, I'm biased. Joe basically took all the text I offered to fix those.
I'm sure Joe didn't take any text without thinking about it seriously. So good. Okay, so after this slide deck's been presented, we will adjust the status of the ones which are closed. Right, we now have a group of items which are less complete. We need to decide on what we're going to say about what some people have called on the list exposure of information which can be used to exploit privacy exploits by an attacker or observer. That for other people, they say, well, it's just a protocol header and all UDP headers are in the clear. So somewhere between one extreme and the other, we need to agree on some text for this issue, which is currently issue 8. And if people with more security clue than me want to help weigh in on that one, then that is okay as well. So quick call out that this item 8 is to add a paragraph to the security considerations that says something about the fact that you're adding an encapsulation around a packet and therefore you're possibly changing its security characteristics because you've added some plain text around it. Issue 9 is, I think, now resolved. Good feedback, comments on this? Go ahead.
Most resolved, looking at the comments this morning. I think we have just a little bit more text to go on that.
On 9. Okay. And please make sure the GitHub says that. Issue 10. Yeah. Okay. Issue 10 is being debated by multiple people in multiple ways, but certainly the pseudocode is not useful the way it is. So we need to decide whether we want this level of complexity and how we write it. And I think we can do that by discussion. I think issue 11 is now closed or will be. Go ahead.
I concur.
Good. I am not at all sure what I feel the issue 12 has reached, which is a design decision. So if anybody wants to chime in on this, please do.
I think your characterization is correct. We still have people arguing about that. You and I may be on opposite sides of this one.
That's okay as well, because I can review my arguments. Is it helpful to talk about it now?
I'm not sure. I added some things to the GitHub this morning before I hopped on the meeting. So maybe let's just take the discussion there.
Sure. That's okay. I mean, the OCS discussion comes from several different perspectives. One of them is whether we should just keep this really simple because making things optional causes code branches, and the people who implement things don't like the possibilities of having to check things and then check whether the code branch was right or appropriate. There are other people who want an OCS to be always there because they see it as a way of checking the sanity of the option space. And then there's an argument that there are certain cases where the OCS adds little value and does add processing complexity. So in these specific cases, we might not need it. Is that a reasonable summary of the 3 ways we're being pulled?
I concur with that. With one addition there, that if we wish to use this in tunnels without checksums, you really want the OCS off if you're using UDP fragmentation in that tunnel, because the OCS in that case is essentially covering everything but the UDP header.
Which OCS?
Yes, on each fragment, and that if you are using UDP with UDP fragmentation in a tunnel where you wish to have the checksums turned off for performance reasons or others, you would want to have it both the UDP header checksum and the fragment OCS turned off for that application, that use case, if it's a real use case.
Yeah. Okay. Yep. I actually agree with you on that one, but other people might not. So let's carry that one on the list.
Thank you.
And then we have the last batch. So for those of you who are hoping for more, there are currently only 18 issues active, of which one has been deleted very recently. Issue 13, I think, can be closed.
Concur.
Issue 14 said more clarification needed, but I think we might be very close to closing it. Do you think we can close that one now with the text?
There did seem to be some ongoing discussion, but we were pretty close to being closed. I think, if I remember correctly, my comment that I posted this morning, it was that I thought it was good as is.
Right.
Okay.
I concur with that, and I suspect the other people have commented on the list on that. So, and I don't know. Okay, number 15, I'd like help with, because I think the statement in 15 is true, but I think Joe doesn't want to comment on how anything uses UDP options. He wants to leave that to the application to decide. So maybe this is like one sentence added somewhere in to call it out very clearly. Is that what we're talking about?
If I understood correctly the discussion, actually this one was the one that I had a comment to. Joe was not wishing to have in the UDP options spec a statement that only DLPM TUD could use these options. And I kind of agree with him on that.
But that wasn't the... Yeah, okay. Everyone agrees with him on that one. But I think the question was, the comment was from another person in the working group who reviewed it in the last call, who said that you can only return a res option when the socket is bound, which I think is now part of DPLP MTUD.
There are two ways to look at this. One is that you have a library that implements DLPM TUD, and you bury that in the socket options, and another is that it's more raw. And in that case, the decision is with the application layer that's seeing these res and REQ options. In any case, the UDP itself does not transmit a response without being told to do so. That was, I thought, the really important part of that.
Right. Okay. So we concur. I think we can finish that.
It's
text
very close to that, I think.
Okay, fine. Good. Clarification. ICMP messages were kind of discussing, but that will work its way out. Yeah. 17 was choosing the right way to say that these arrant and naughty middle boxes do silly things with our packets. Yeah, we'll figure that one out. And Joe was going to add some of the design principles he'd already presented, which I presume will become text. So yeah, go.
I added one more this morning, which was a typo, a really small typo in the latest draft. It should be trivial and uncontroversial to fix, but it's important to make sure it does get fixed.
Okay.
Something says there's a missing knot that should makes it say the wrong thing.
Oops, always dangerous. Okay, well, thanks. My purpose in just spending 10 minutes going through these is just to bubble this up so people can see that we are using GitHub to try and close the issues which other people have raised. We are, as a group, totally open to people commenting on GitHub or on the mailing list about these issues. They are by no means sorted out. and they are by no means finalized, but they are being carefully checked by Joe, and most of these will be addressed in Rev 24, with the intention that then the draft can proceed to a final working group last call to confirm its publication. So that is the plan. Anybody got any comments on the plan? So with 1 minute to go, my final task is to wish you all a pleasant September and October. Please keep in mind that the working group is trying to finish some documents before the next meeting, and to also come up with some very clear guidance for the SCTP and DTLS work. Please try and read comments on drafts and come along to our meeting in the IETF in November. We will have some new work to show, I believe. There are people asking for new work to be brought to the group, so we will have some new items also. We have a set of notes prepared by Hannes and anyone else who contributed. I see a number of people joined in online. If you want to go and check those, that would be very useful. And then we'll upload those to the proceedings as well. So thanks ever so much for spending 2 hours of your time talking about TSVWG issues. Bye-bye.
Maybe that's the